Hey everyone, and welcome back to the channel. For millennia, humanity has gazed up at the stars and pondered the nature of our existence. Is reality truly as it seems, or is there something more, something fundamental, that lies hidden beneath the surface of our perception? Philosophers throughout history have wrestled with these profound questions, from Plato's allegories of shadows on a cave wall to Descartes' skeptical inquiries about an evil demon deceiving our senses. But what if these ancient doubts weren't just abstract thought experiments? What if modern science, with its powerful telescopes, quantum accelerators, and intricate mathematical models, is beginning to whisper something far more unsettling? What if the universe isn't quite as real as we've always believed? Today, we're diving into a mind-bending mystery that some scientists are seriously considering. The startling possibility that our entire cosmic existence, every star, every galaxy, every particle, might just be part of an elaborate, simulated reality. This isn't science fiction anymore. It's a frontier where physics meets philosophy, and the implications are utterly staggering. Prepare to question everything you thought you knew, because the universe, it turns out, might just be a brilliantly crafted illusion. Our journey begins not with grand pronouncements, but with the quiet, unassuming numbers that govern everything. These are the fundamental constants of the universe, values like the speed of light, the strength of gravity, the mass of an electron, and the precise charge of a proton. These numbers are baked into the very fabric of reality, dictating how stars burn, how atoms form, and ultimately, whether life can exist. And here's where the mystery deepens to an almost unbelievable degree. These constants are calibrated with an astonishing, almost impossible precision. Consider gravity, for instance. If the gravitational force were just slightly stronger, stars would burn out much faster, collapsing under their own immense weight before complex life could ever evolve. If it were even slightly weaker, galaxies wouldn't form, and the universe would be a diffuse, lifeless haze. The cosmological constant, a value related to the energy density of empty space and responsible for the universe's accelerating expansion, is perhaps the most extreme example. Its observed value is so infinitesimally small, yet non-zero, that if it were just a tiny bit larger, the universe would have expanded so rapidly in its infancy that matter would never have clumped together to form stars or galaxies. If it were slightly smaller, the universe would have quickly collapsed back in on itself. We're talking about a precision that, in some cases, is likened to hitting a target the size of a single atom located on the other side of the observable universe with a dart. This phenomenon is known as the fine-tuning problem, and it's one of the most profound puzzles in cosmology. Why are these fundamental constants set to such exquisitely precise values, all perfectly aligned for the emergence of complex structures and, eventually, life? The traditional scientific explanations often lean on the anthropic principle, which simply states that we observe these specific values because if they were any different, we wouldn't be here to observe them. It's a self-selection effect. Of course, the universe is conducive to life because we are living observers. However, for many, this explanation feels somewhat unsatisfying. It's like saying, I won the lottery because if I hadn't, I wouldn't be holding the winning ticket. While technically true, it doesn't explain the incredible odds. Another scientific hypothesis is the multiverse theory. Perhaps our universe is just one of an infinite number of universes, each with its own unique set of physical laws and constants. In this vast cosmic lottery, it's inevitable that at least one universe would hit the jackpot, developing the exact conditions for life to flourish. And naturally, we would find ourselves in that particular universe. Multiverse theory offers an elegant solution to the fine-tuning problem by pushing the problem out of our immediate universe and into an unobservable, larger cosmic landscape. But even this grand solution raises another question. If there's an infinite number of universes, each with slightly different parameters, what mechanism generates them? And how can we ever test such a hypothesis if we can't observe these other universes? This brings us to a far more radical, almost dizzying possibility. What if the fine-tuning isn't a cosmic accident or a consequence of an infinite lottery, but rather a deliberate design? Not necessarily divine, but intentional. This is where the simulation hypothesis steps into the spotlight, suggesting that our entire universe could be a sophisticated computer simulation, created by a vastly advanced civilization. The concept isn't entirely new, but it gained significant traction with a 2003 paper by philosopher Nick Bostrom. His argument, often called the trilemma, posits that at least one of three propositions must be true. 1. Civilizations almost always go extinct before becoming posthuman, i.e., technologically capable of running realistic ancestor simulations. 2. Posthuman civilizations almost never choose to run a significant number of ancestor simulations. 3. We are almost certainly living in a computer simulation. Bostrom argues that if the first two propositions are false, then the third must be true. If advanced civilizations are possible, and if they have the computational power and inclination to simulate their ancestors, or simply to create complex, realistic worlds, then the number of simulated realities would far outweigh the one base reality. Therefore, the statistical probability that we asterisk are in one of those many simulations becomes overwhelmingly high. Think about it from a computational perspective. Civilization reaches a level where they can perfectly replicate a universe, down to the quantum level. What would that look like from the inside? For us, the inhabitants of the simulation, it would be indistinguishable from reality. Our sensory inputs would process the simulated data as genuine, our memories would be of simulated experiences, and our scientific instruments would measure simulated